The first video looked at what geology was and what geologists do. This one's going to look into what the interior of our Earth actually looks like. There are going to be some pretty big words in here that you're going to be expected to know, so make sure you take careful notes. First thing you need to know is temperature. Temperature is actually an average amount of thermal energy in an object. But at the beginning of Earth, as like the outside, as you make your way down, first the temperature is going to get cooler as you start digging through the Earth. And about 20 meters down, the temperature is going to start increasing about 1 degree centigrade every 40 minutes. So keep that in mind. Outside, it gets pretty warm. As you start digging, you're going to get into cooler temperatures, roughly around pretty much a constant like 58 degrees down there, until you get to a little deeper. Then it's going to start slowly getting warmer and warmer as you get further in. Also, you're going to have to realize pressure. The deeper you go, the greater the pressure is going to be. Think about how much stuff is above you pushing down on top of you. So just to keep in mind what pressure is, the force of pushing on a surface or area. Basically, the weight above where you're at, all that rock above you, is going to be pushing down on you. So it'd be like holding up a mountain underneath you for the amount of pressure you're going to experience. The Earth is made up of layers. We break those layers into 3 categories. They do have some subcategories to them, but our main 3 layers are the crust, which is the outermost layer. Underneath the crust, you have a mantle, and underneath the mantle, you have a core, which actually gets broken up into a few different layers as well. So here is just a little diagram of a slice of Earth. You can see the crust is over here. That is the thinnest. It's 0 to 100 kilometers in thickness. And then the upper part of the mantle comes in there. And then the mantle and then the cores and stuff like that. We'll talk about the different structures as well. So let's look at the crust. The crust forms the Earth's outer skin. There's our little graphic telling us, hey, here's the crust. It's the outermost layer. This is the stuff you interact with because you live on the outermost layer. So you probably know what rocks are. You probably know what mountains are, soil and water. All these things are found on the Earth's crust. The thickest layer of the Earth's crust would be like where there's a really, really tall mountain and you have to drill down. The thinnest layer would be pretty much underwater. In the ocean trenches. So the thinnest layer of the Earth crust is only going to be 5 to 40 kilometers thick. It's really not that thick compared to the other layers, at least. The crust does include both dry and wet, or the ocean floor, so the dry land and the ocean floor. The ocean floor we're going to call oceanic crust, it has the word ocean in it. The land floor, or what you call it, we're going to call continental crust. That's what we find on the continents. Oceanic crust is going to be mostly basalt, and continental crust will be made of mostly granite. Keeping in mind, basalt is much more denser of a rock compared to granite, which will come into play later on when we look at plate tectonics and subduction zones. Once you get past the crust, we get into the mantle. This is the area below the crust. So this is 5 to 40 kilometers down, right? Because the thinnest part would be about 5, the thickest part would be upwards to 40, into the mantle. The upper part of the mantle and the lower part of the crust we're going to kind of combine into one layer itself that we're going to call the lithosphere. Lithos meaning stone. And this is going to be a rigid layer of hot rock. It is a solid layer. So part of it's part of the crust, part of it's part of the mantle, but it is all solid in here. So keep that in mind. Underneath that lithosphere is going to be the asthenosphere. That's below the lithosphere. Athenos is the Greek word for weak. Here your temperature and pressure are going to increase, and therefore this layer is going to be a lot softer than the solid lithosphere, and this material will actually be a fluid. It can flow. So the mantle is about 300 kilometers thick. So keep going down. After the mantle, you get to the core. The core is divided into the outer and the inner core. it does behave like a thick liquid, so very viscosity is a resistance to flow, so you have a very high viscosity liquid here. It is going to be comprised of molten metals. There are other elements in there, but the main metals that you need to be concerned with is Fe for ferrous, which is iron, and Ni, which is nickel. So ferrous and nickel, or iron and nickel, surrounds that inner core. Now these two metals are extremely important because they are magnetic in properties, so they are going to help give the Earth its magnetic poles. The inner Earth, my face kind of covers that a little bit. Move up here for now. The inner core, sorry, at the very, very middle of it, that is going to be, the pressure is going to be so great that it's actually going to become a solid. So the outer core does have this kind of viscous metal thing going on, but the inner core is going to be pretty solid, and it is going to be that solid iron and nickel as well. The inner core makes up about 33.3% of Earth's mass, meaning it is an extremely dense area. You get that density because, one, it's made of the metals, which are dense in themselves, but you also get that high temperature and pressure happening. So the inner and outer core together are only going to make up 15% of the Earth's volume. So we do get that real density. So if you think the core is just slightly smaller than the moon, let's put my face back there so you can look at our graphic a little bit, and you can see we have our core right here. It's divided into our inner and outer core.